With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, so we are given with the question which says for maximum range R, an orifice is made at a depth h from the upper surface of an incompressible liquid. If the height of the liquid column in open vessel is 100 meter, then the value of small h is. So we have been given with the height of liquid column, that is 100 meter, and let's suppose it has to be capital H. Alright, so and we have made an orifice at a depth h, small h, from the open surface, and we are interested in finding the maximum range, that is this value of R. Alright, so first let's try to calculate the value of velocity with which the liquid is coming out. Alright, so this can be calculated using a third kinematical equation, that is using v square equals to u square plus 2as. Alright, that is velocity and displacement equation. So from here we can say at initially the liquid is at rest, and finally when it comes out from an orifice it has some velocity. Let's suppose it has to be v, and initially its velocity is to be considered to be as 0. Therefore we can say, and the distance it is covering is h, so we can say v will be nothing but under root of, and a is acceleration. Due to acceleration it is coming down, so 2g, and s will be h over here. So this is the velocity with which the liquid is coming out, and also we know this velocity as velocity of efflux. Alright, now first we have to calculate the value of time it will take to reach the ground, and velocity we have with us, so we will just calculate the value of R. Therefore now we can use again the second kinematical equation, that is we can say now S is equals to ut plus of half at square. This is what the second kinematical equation speaks. So the displacement from here to here, we can say this displacement will be nothing but it is capital H minus h. Alright, so the time it will take to cover this much distance, we can say that is h minus h will be equals to velocity with which it is. Here velocity will be taken as 0. As we can see over here, there is no vertical component of velocity acting. This velocity with which it is coming out is a horizontal velocity. Alright, so here the velocity will be 0 in this case. Now so and here we can see acceleration due to gravity is acting in the downward direction, and displacement is also in the downward direction, so this will we can keep it as positive only. Alright, so from here we can say the value of time it will take to reach the ground will be nothing but 2h minus of h dividing it by g, and with a root over it. Alright, so this much time it will take to hit the ground. Now we can say we are interested in finding the value of R. So R we can write, R will be nothing but R will be velocity, that is horizontal velocity, because R is a horizontal distance, so it will be horizontal velocity will be responsible for it to get covered. So V into, and time taken as t. Alright, the moment it hit the ground, the time will be the same as this. Alright, so now we can just substitute the values over here. So this is nothing but it is under root 2gh, and this is under root of 2h minus h by g. If we solve it further, so we can get the answer as 2 under root of this can be written as h minus of h into h. So this is the this is what the answer we are getting, or the result we are getting for range. Now we are interested in finding the maximum value of range as per the given question. So for maximum range we can say for R max, so let's take it over here. For R max we will use the concept of maximum and minimum, so we can write it as dr by dh will be equals to 0. Alright, that is the for maximum we can say the slope has to be 0. This part of maxima and minima we have already covered. So if we differentiate the above equation, that is, let's say this is the equation which we are going to differentiate of range. So we can write dr by dh. We will just apply the chain rule. First we will take the derivative of entire term, and then we will take the derivative of inside term. So for taking the derivative of entire term, we will take 2 as common outside, and here it will be root x. So root x derivative is nothing but 1 upon 2 root x, and here x is nothing but x is nothing but it is we can write this as 2 h minus h into h. So this is what the derivative of the entire term we are getting, into the inside term derivative will be, here it is h minus of 2h. For h square it is 2h, and for h into h it is capital H only. Alright, and that is equals to 0. Therefore we can say h will be equals to 2h from here. Alright, or we can say this as h will be equals to h by 2. That is, therefore we can substitute the value of capital H that has been given to be as 100. So we will get the value of small h, that is 100 by 2, and it comes out to be 50 meters. So at the 50 meter depth an orifice can be made for maximum range. Alright, so this matches with option C. So I hope you have understood the concept, and thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.